Algebra 2, Lesson 55, Advanced Abstract Equations and Word Problems and Quadratic Equations. Alright, so starting in the practice, we're going to start with B. They tell us to find M, and then they give us this crazy looking equation with nothing but letters. This is really going to test your algebra skills and how they relate to fractions and common denominators. So, here we have this equation, and the letter we're looking for, M, is already in the denominator. So first thing, we got to get that number in a numerator so we can deal with it. And the best way to do this is to find the common denominator of the whole equation, which is going to be x times parentheses m plus z. And then we'll multiply every single term in this equation by that common denominator. And that'll help get all of our letters out of the denominator. We'll be left with nothing but whole numbers there. So, starting with the first one, we multiply by x m plus z. And that's going to cancel the x's, and then the ay will distribute. So that gives usamy plus ayz. Alright, so that's our first term. That one's done. And then the second term, we've got this times x parentheses m plus z. So here, what we'll cancel is the m plus z. The m plus z's cancel, and then we're just left with plus cx. So we have that plus cx, and then last one, we have this times x m plus z. S times x is very simple. They just become sx. So we can take these two numbers and then distribute them. So then we get equals msx plus sxz. All right. So now our equation no longer has fractions, and we've got two m's. So let's get all those m's on the same side, and then we'll move everything else on the other side. So I'll go ahead and I'll move this amy, or Amy, over to the right side, and I'll move sxz to the left side. So subtract amy from each side, and then subtract sxz from each side. That cancels, and then I get ayz plus cx minus sxz equals msx minusamy. Now, the next thing I can do here is, now that my m's are all on the same side, is I see that they are now a greatest common factor of this polynomial. So I can factor them out as m times sx minus ay. And that's going to equal all of this. And then the last thing I need to do is to just eliminate sx minus ay. So I do that through division. Divide by sx ay. That cancels. And then I can take this entire side and write it over sx minus ay, and m equals all of that. So that is my final answer. Alright, so there's a lot of work to do here. The main thing is, when your unknown is in the denominator and you got multiple denominators, multiply everything by the common denominator. That gets it written as a whole, as whole numbers, or non-fractional integers. And then from there, we just have to group, factor out our unknown as the greatest common factor, and then divide by the coefficient to get our unknown. Now we have consecutive integer word problems and quadratic equations. So let's go to practice C. They tell us to find three consecutive integers such that the product of the first and the third is 5 greater than 5 times the second. So again, consecutive integers, the first one is always going to be n, and it always helps to write this on your paper so that way you don't get confused and you don't forget. The second one is going to be n plus 1, and the third one will be n plus 2. Now, I have to write an equation of this. They tell us the product of the first and the third is 5 greater than 5 times the second. Always remember, is like your equal sign, so this is going to be like the middle of the equation. So I just have to figure out the product of the first and the third. So that's going to be written as n times the third, which is n plus 2. And I got my equal sign. Now that is 5 greater than 5 times the second. So we have to do 5 times the second first. So we'll do 5 times parentheses n plus 1, and then 5 greater than that is just that plus 5. It always helps to do your greater or less thans at the end of your equations, so that way you don't get confused with any subtraction or anything like that. So now all we have to do is just solve this equation, right? So we'll distribute this. That gives us n squared plus 2n. And that's going to distribute and give us 5n plus 5. And then plus another 5. So I'll go ahead and combine these. That'll become plus 10. And I'll move all my n's to one side, and you can already see I've got a quadratic here. So I'm going to move the whole quadratic to one side and see if it'll factor. So I'll subtract 5n from each side, and I'll subtract 10 from each side. That cancels, and on the left side we're left with 0, and then here we combine it to get negative 3n minus 10, and we're going to hope that this will factor. So let's see if it does. N and n, and then is there anything that will add up to negative 10? We'll have a plus and a minus since the last term's a negative. That will also combine to become negative 3. Well, if I do positive 2 and negative 5, that would work. Okay, so positive 2 and negative 5 would work. They satisfy the equation. Now the possible values for n become positive 5, if you remember our zero factor theorem, become positive 5 or negative 2. Now, how do I find my answer if I've got two possibilities? Well, that's easy. We're just going to use both of them for our answer. So if n is 5, then the answer would be 5, 6, 7. If it was negative 2, then it would be negative 2, negative 1, 0. And don't forget, when you have negatives, you have to solve them by adding 1. Don't make the mistake of putting negative 2, negative 3, negative 4, because those are less than. Negative 3 is less than 2, whereas negative 1 is greater than 2. So remember, you're always counting to the right, and that's our answer. It would be this or that.